Okay, so on this tutorial we're going to be covering the Bluetooth, the HC-06 and the BMP pressure and temperature sensor, and we're going to be using an Android application made by I believe it's called Qul.com, and the application's called Bluetooth Electronics. It's got a fairly reasonable interface, and obviously you've got the ability to create and edit your own applications, and you've got sliders and your different controls and things. You literally just drag them on wherever you want them. And I'm going to be going into detail on this later on, to show you how to set it up and have the two communicating. So what I'll do is we'll actually build up the unit itself. I'm going to do it really simply. Basically, these Bluetooth modules the only support the input for 3.3 volt logic. They advise using a voltage divider to the RxD, which is the receive pin for the Bluetooth from the Arduino. The Arduino will take a 3.3 or a 5 volt in or out. On the TX RX it makes no difference with the except for this won't take the 5, so they say. I have ran it at 5. I've tried it with a voltage divider as well, and I found that it's for my project it's not suitable. It's been powered by a lithium battery in this box, and the divider itself was actually drawing around about 50 milliamps, which is no good for my project. I mean, the circuit alone is going to be running at around about 35-40 when the Bluetooth isn't connected and it's trying to get a connection. So it'd have been like 100 milliamps. It's not ideal for what I'm wanting, so I had to do away the voltage divider. I have found if I just run a 10k in line with it to the from the TX to the RxD on the Bluetooth, that it's only pulling around about 9 nanoamps, so it's a very small amount. It is still at 5 volts, but like I say, I mean, I've got 2 projects that I've done before. One's been running for over a year, and that's literally built exactly the same. It still works to this day. There's nothing wrong with it. It's not done any damage to it or anything. I mean, it is at your own risk. I'm not advising that you do it this way. Your boards or things that you might be using may be slightly different, and you may get different readings to what I've gotten. So I would test and check the current draw to the RxD. But like I say, I don't advise it, but this is the way I'm going to be building it today. So what we'll do is I'll show you quickly how I'm going to build this one up, and then we'll have it connected, and we'll go to the Arduino sketch, and then I'll run through the code and how this works. So connect the ground and the VCC. See, the RxD and the TXD on this it's basically the reversal of the ones that's actually on the Uno board itself. So I found it easier I can actually just plug it straight in like that, you see. Also with this board, we've actually got a breakout here as well, where I've actually got 2 3.3s, 2 grounds. Well, actually there's 4 grounds, and then I've obviously got the SCL and the SDA also available on these pins here. I'm not actually going to be using them, and an RxTX and 5 volts as well. So I'm just going to connect this to the 3.3 volts and the ground. For the regular Uno boards, you'll have to just connect them here. You may need to use a breadboard, because there's only the one 3.3 there. You don't have to use 3.3. You can run them at 5 volts. So the BHP is you've got your voltage. That also runs between 5 and 3.3 volts. It will run on both, but we're just going to use the 3.3. Like I say, we need to keep I'm trying to keep the usage to a minimum. And for this one, the SDA and the SCL. The SDA actually goes to the analog 4, and the SCL goes to the analog 5. So I'm also going to do the same with this one. I'm just going to plug that in like that, just to save with wires. And I'm also going to connect that to the 3 volts, 3.3, and the ground. The beauty of these Bluetooth modules is that you can pretty much plug and play as long as you've got the code. I'm going to upload the source code. It's the SparkFun that I've used. There includes. I've rewritten the code myself. I'm taking a lot of theirs out, as we're not going to be using the pressure side of it. We just want the temperature readouts, obviously for the app itself. Also, I'd like to add that whenever you're changing anything on your code, before you actually power this up, make sure that you unplug the TX and the RX, because it will interfere with the upload of the sketch to the Arduino itself. So what I'll do is I'll power this up, I'll show you the code, and then we'll upload the sketch, and then I'll show you the serial monitor, and then we'll come back to the actual app itself, and I'll show you how to quickly build one up and get this working. I'm also going to be covering a similar one on another part, which is going to be covering, it's using the same application, but it's going to be using the 8-channel relay and how to set up the switches and things like that to control these. And also I've added a timer in there as well, just to shut the whole lot off. Like I said, the only difference is going to be the same wiring for the Bluetooth, except for we won't be using the pressure and temperature sensor. Okay, so this is the code we're going to be using. I've also included on here, in case you're unaware, the different connections, and obviously the voltages and the voltage divider as well. Like I say, I mean, I was only pulling around about 9 nanoamps at 5 volts. That isn't going to do a great deal to anything. So I've actually I did away with that. I've just used a 10k in line with the just in case there is any spikes at all. But like I say, I've ran one for a year and there's not been any problems at 5 volts. So what I'll do is I'll just quickly take you through the code. So obviously we're using the SparkFun's include here for the BMP180. Wire already comes with the Arduino IDE itself. Basically the first part here is just calling upon the pressure sensor to start it up. And then obviously these are just the readouts. So serial will begin at this 6900. You can change that. Just remember to change it on your panel. You'd also may have to reconfigure the Bluetooth. I believe the HC-06 is defaultly configured to the 6900. If it's a HC-05s, I believe it's a higher rate. I'm not sure of those. Obviously it's sending the new line and then connecting for the serial, and I've just delayed it for 1.5 seconds just to add a bit of drama. Then it will obviously pressure begin, which is the call for the pressure to start up. Any faults whilst it's connecting, it'll throw up here. If there is no faults, you'll get the connected serial print, and then it'll go straight into the loop then. All we're going to be using is just the T part of it, the function. I'll show you the original code. Like I said, I'll put it all in a raw file and upload it to a file site, and I'll drop the link in the description. So it'll start the temperature read here. I'll send the signal to the pressure sensor to get the callback of the actual temperature, and this is when it's received, and then I'll obviously print the string. The app that we're going to be using, it requires a star and then a character and then a star for the end. We've had to add this string here. This is some of the bits that I've actually changed from the original. So basically it'll use a serial monitor, which the Bluetooth's going to be taking the side of for the application. So basically it's we're wanting a T, so the script code itself is going to send the T. The reason I'm using the T is because it was already in the original code. I don't want to mess around with it too much, just in case people are used to the original. But like I said, I've taken the majority of it out. It will send this string, and obviously the end character here, the 1, is literally just for the readout. So with the 1 in there, let's say it's 23 degrees, it'll also give you the decimal, so it'll be point and then whatever the decimal is. If you didn't want that and you just wanted the the actual degrees without any decimal points, just change that to a 0. If you wanted the 2 digits after the decimal, you just set that to 2. It's nothing really hard to change. So what we'll do is we'll quickly upload this to the Arduino, and I'll show you the serial monitor, the actual data that's been sent through the serial. Okay, that's now been sent. Okay, I'm just going to reconnect the TX and the RX. Now I've uploaded the code back on the Arduino. Okay, and I'll just move this over here, and we'll open up the serial monitor. So as you can see, we're getting the connecting status and connected, and now we're getting the data coming through, which is the start T 24.3 degrees, because I've left the 1 on the end of the string here. So that's the value that's been sent through now. What I'm going to do is now I'm just going to quickly unplug the BMP, just to show you that it will throw out faults if there's any faults occur during any readings, which is the bottom part of it. I mean, you can change this in here to whatever you like, really. I just literally just quickly did them. Just don't ask why I put what I put, but like I say, once the connection's re-established, straight away it'll come back and it'll start reading again, so there's no problems there. What will happen is I'll just quickly close the serial now, and I'll disconnect it. On startup, if there's any problems, you'll actually get up the 1 in here after the fault, so it'll read out this, and it'll stay in that until it's been reset, basically. So if you do get that come up, just check your wiring and make sure everything's wired up, and make sure they're the correct way as well. And once you've established that, literally just close your serial monitor and reopen and just check. If you get the connected, and then you start getting the data coming out, you're pretty much ready to go. So what I'll do now, I'll take you over to the app, and I'll quickly show you one just as a demonstration, and then I'll actually quickly build one up as well, just to show you pretty much how easy it is to use. So quite a good interface. The only downside of it, I wish there was more control over certain things in there, and I wish they'd probably add or update it a little bit more. I'm pretty sure I've had the actual app for over a year. I've never really used it up until now, but I haven't seen any updates or anything like that for it, so there's not been many changes, or if any, since the release. So whether they've ceased work on that, I'm not too sure, but I'm hoping that if we get a bit of interest onto the site, that they might actually update it, because like I say, they've got a great idea there, and it's really simple to use. So okay, I do apologise about the brightness. I've had to actually turn my light off. As you can see, when I put the light on, you can barely see the screen, so I've had to turn it off just whilst we do this, so that's why it's a bit dark. Okay, so let me just bring this a little bit closer so you can see. So obviously you got your text box. We're going to add a second text box as well. So the first one, just click the edit. Obviously you've got the text there. We don't want any text. Okay, so default text needs to be set as nothing. We'll leave that set to the left. They're the colours. If you wanted to change the colours, it'll give you an indication here as to what colour it is it's been set to. So if I just move the sliders, you see it'll change change the colour of this box here. That gives you an idea of what it's going to come out like on the actual app. But all we need to mess with is this receive character here, which is obviously the capital T. So we'll add the capital T, click done on there, and then OK. So that will now receive, it'll actually print out the data that's coming from this. So now we'll go to the setting text box. This one itself, we're not wanting it to receive anything, but so we're just going to put the 0C in there, which is already defaultly set on the right hand side. We don't need a receive character for that, so we can leave that as is, and then we're pretty much good to go. So if I go back now and then run the project, which is that one, and it's changed it back for some reason. Right, up. So I'll go back to edit, delete the text out of there, and want 0. Oh, sorry, actually, no, we don't need the 0. We just need the degree symbol and the C, capital C. Click next, and then done. Okay, so that'll give us the end bit that we wanted on there. So we'll go back again now, and then we'll run the project again. And as you can see, it's given the readout. You can actually change where the positions are on there. I thought I'd set that to the far left, but it is an option. So it's at the moment set to the left, so we'll just put it fully on the right hand side of the actual box itself, and that'll reposition where the degree C is. So obviously you can actually read it better. Obviously that's the colour we changed it to, like a bluey purpley colour. So that's giving you the 24.3 degrees. So it's actually giving you the, so you can actually see what the actual text is as well. If you wanted to add any other things to it, like a different indicator, let's say like one of these bar ones here, it's pretty much the same, exactly the same thing really as the other. Position it where you want it, and just edit the text within inside. So you've already got the T already in there, capital T. So then we change the minimum values. So remember that's a text, so that would be 0 degrees and C. That one will be 50 degrees and C. That's 0. That can be left as it is. Must be set to 50. Divide can stay as it is. Subdivisions, and then OK, and that's pretty much done. So if I go back now and run it, you're also getting the readout here as well. Like I say, because of your divisions that you've got, you can actually work out without actually needing that. If you know, I mean, it says 0 and then 50, you can work it out pretty much then. You've got your 10 major divides and then your 5 in between, which is what we set it to. So you can pretty much work out what the temperature is. Like I said, there's other things you could add to it, I suppose, if you wanted to. What I'm going to go into as well is obviously the other application I was using, which is this one that which is what I'm going to be doing on the next tutorial. It's this is the one that I designed for the 8-channel relay board. For this 8-channel relay board, let me just turn the light back on. So that's for the 8-channel relay board. This one here, this app that I've got, and I'll be showing you how to set that up and how to letter these on the next tutorial, and obviously it'll cover this. The setup for the Bluetooth is exactly the same. The characters that's been sent back and forth are pretty much the same, and I'll include the sketch for that as well, as long as you've got the original one for the actually no, it doesn't really matter, to be honest. I was thinking about the BMP, we're not going to be using that, so you don't actually need any other code for it. I pretty much wrote it on the basis of what's already with the Arduino IDE itself, so that should be pretty much straightforward. But like I say, I'll cover this on the next tutorial, and let me show you from there. Okay, so what I'm going to do now is I'm just going to move this one out of the way, and I'm going to show you the actual box one that I'm actually using now. Basically, I used the Pro Mini. Like I say, apart from the thing, I've not really stuck anything in place. A lot of the times when I build these projects, and I tend to pull them apart again not too long afterwards. I don't want things permanently in there, but basically I've used the Pro Mini board, and as you can see, I've just soldered the BMP on in there. I don't know whether you can see that actually, but the 2 pins. See, I'm only needing the 2 pins on this side here, is because they're located slightly off center, and obviously the VCC is connected there, and the ground is just a little loop over here. So that's straight in. There's a 10K in line on the receive pin for that, because it's more of a permanent one. Like I say, it doesn't get warm or anything. There's no excess amount of current or anything. And then we've got obviously the charge circuit, which is built in here, and an old lithium. An old LiPo cell, which is what we're using to power it up. And obviously the Bluetooth connects up pretty much the same. I've just covered the wires up here, but like I say, with it being loose, it doesn't bang about in there or anything like that. It's just I didn't want anything shorting out. So that's pretty much it. And obviously the power switch is on this side here. When that's turned on, obviously it powers up. It's waiting for the connection. Got the light there for the Pro Mini, showing that you've got power. And then obviously I've tried to locate the sensor itself as close as possible to where the hole is that I've drilled out on that side, just so it can actually get the air and pick up the temperature. So thanks for watching, and like I say, I'll upload everything that you're going to need and put it in a RAW file, and literally all you're going to have to do then is just download it from there, unraw it, and you'd need to drop the actual the BMP, so the SparkFun, that'll need to go directly into your main Arduino files in the libraries, and make sure that you restart the Arduino IDE before you actually try and find it, as it probably won't locate it. Once you've done that though, you're pretty much good to go. The sketch itself I just dropped into your document sided Arduino file for your own sketches, and you're pretty much good to go. Any questions or anything that you're not sure of, just leave a comment, and I'll get back to you as soon as possible. I am going to try and do more videos. I do a lot of projects, but because of the length of time, I'm never sure on the length of the time it's actually going to take me to do some of the projects that I'm involved in. So I don't actually record them or cover them at all. It's a shame really, because like I say, a lot of the things that I do, it'd probably interest a lot of you. I do some pretty crazy things with electronics. And I will try and cover them. At the moment though, I'm limited with YouTube to how big the videos are, so I can't really cover anything like that I cover, as I just wouldn't have. It'd have to be in like 4 or 5 parts, or probably more, because like I say, some of them go on for hours. But anyways, thanks for watching, and like I say, if there's any questions or anything like that, just please leave a message in the comments, or anything that I haven't covered, something I might have missed. Just add it in the comments, and I'll get back to you and make any adjustments as I need to. So thanks for watching.